In the video previous to this one, we worked on problem 5 here, and we did parts A, part B, and part C, which have been pretty straightforward vector calculations like we've been working on before, just finding resultants using our trig functions. So we have all those solutions here in that previous video, but now we're going to add a piece that we haven't done yet. And it says we need to calculate the angle upstream that the boat would have to head in order to end up directly east of where it started with no downstream drift. So you can see in this problem that we were heading across at 15 meters per second and downstream at 7, and we found this resultant of 16.6 meters per second. So I know it would be tempting at this point to say, well, if that's what it was downstream, all I have to do is just turn up at that angle and go 16.6 meters per second. I'll end up straight across the river. But the problem was we figured out that our boat's maximum velocity is 15 meters per second. So our boat can't actually do 16.6 meters per second. If we had done this with a smaller velocity, we maybe could do that. But I know it's tempting to just point it upstream at 25, but that actually won't work in this case. So let's talk about how we can do it. So part D here, I've got my river yet, and my boat is headed downstream at 7 meters per second if I don't do something to counteract that. So I'm going to turn this boat upstream, and I'm going to do it as fast as I can, 15 meters per second. And I need the upstream, or the vertical vector component of this thing, to be 7 meters per second to cancel out this downstream 7 meters per second. And if we look at this like a triangle, I want to know what this angle upstream is. And if you look at that, that has an angle, the opposite side of the angle, and the hypotenuse. So the sine of theta is the opposite over the hypotenuse, but we need the angle, so we're going to use our inverse sine function here. We'll plug those in. 7 over 15. Again, leaving the units out of this. Inverse sine 7 over 15, and we get 27.8 degrees. So if we turn that boat upstream at 27.8 degrees, the vertical component is going to be 7, and then we'll end up directly across the stream right here with no downstream drift. But just like anything else, it comes at a little bit of a cost. If we turn our boat upstream, it's going to reduce the amount that we can go across the stream, or our horizontal velocity. So then part E says, calculate the boat's eastward velocity as it heads across at the angle you found in part D above. All right, well, so here we go. We know that our angle is 27.8 degrees. Let's just use that calculated angle to find out what this side would be. Now we can do that a couple of ways. We could use Pythagorean theorem. We could use an a squared plus b squared equals c squared kind of problem like that. Or we could just use the angle that we calculated. So it doesn't really matter, but I'm going to go ahead and use the angle calculation, and it'll make the video a little bit longer, but you can stop it if you don't want to watch it. We're going to use the adjacent side and the hypotenuse. So that's going to be cosine. Okay, and I want to find the adjacent side, so I'm going to do a little rearranging here. The adjacent side would be equal to cosine theta times the hypotenuse. So that's the cosine of 27.8 degrees times 15 meters per second. And I get 13.3 meters per second. Now, the danger, of course, of doing that calculation is that it's using a previously calculated number, which introduces any error from that into it. A better solution might actually be to do the Pythagorean theorem thing with 7 and 15. So let's just do that as well, and we'll double check ourselves. So I know x squared plus y squared equals r squared. In this case, I've got r, but I don't have the x component here, my horizontal. So I'm going to have x squared plus 7 squared equals 15 squared, which means x squared is equal to 15 squared minus 7 squared. Okay. So 15 squared minus 7 squared is 176. And I don't want this x squared, I want x. So the square root of x squared equals the square root of 176. And x equals square root of 176. And I get 13.26, 13.3 meters per second. And sure enough, those two things match up. So there you go. There's how you solve that problem.